In this video, we're going to take a look at the thought process to designing complex parts in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we are going to take an approach, or we're going to talk about the approach for creating complex parts. Now, this is a comment that came in when I was asking for ideas on surfacing, and while this isn't necessarily a surfacing video, there are elements of surfacing tools that we could use here. So what I'm going to talk about is going to be what we're designing. I'm going to talk about some of the main approaches, the things that we need to decide before we get started, and some of the options that we have. So what we're doing here is this is an extruder for a 3D printer. Now the extruder in this case has a fan that blows across these cooling fins, and then there's another fan that is going to be blowing down to cool off the end nozzle. So we want to think about the geometry that we're dealing with here and some of the constraints that we might have. So the user that sent this in said that it was okay for me to share and show in a video, so that's what we're going to do here. Now, the problem that we often run into with things like this is when we get started with either surfaces or potentially forms, and we go to create our solid at the end, we run into the issue of not being able to thicken it or shell it. Now, the problem with that is we run into issues with curvature, radius in corners, things like this area here that get created organically when you're building out these shapes. So what I'm going to talk about is going to be the approach that I would take for a part like this, some of the reasons why, and some of the areas where you can sort of change your approach. So the first thing that I'm going to talk about is going to be the input, what we're dealing with here, and that is the fan. Now, there are two main types of computer or electronics fans that we're dealing with, ones that suck air in one side and blow it straight through, and ones that suck air in and have this sort of squirrel cage and blow it out in a different direction. So we've got axial and radial type fans. Now this type of fan that we're dealing with here typically does better with back pressure, which means that we don't necessarily need to worry so much about perfect flow through a system of ducts. Now, it's not going to be a perfect solution, but these are the types of things that when we look at a design, we need to consider. Now, other thing that we really need to think about is that these fans are rotating and blowing out this big opening here. However, after about 50% of that opening, you have very much diminished returns. There's not really much going on over here, but we don't really want to just block it off. Now, I have built fan cages before that rotate up inside the housing and duct out of a very small portion, and they do work pretty well. It really depends on the fan, and in this case, we don't have the profile of the blade or anything on the inside of it. So what we're going to be doing is working with this entire opening, but noting that we need to neck it down relatively quickly. Now, when we're starting a design like this, there are two main approaches that we have to think about, and these are independent of whether you're solid modeling or surface modeling or form modeling. That's going to be, are we going to build the inside volume of the part, or are we going to build the outside of the part? Now, in a case like this, I would opt toward building out the actual inside volume as a solid body that can be cut away from some other shape. Now, the reason I would do that is sort of twofold. One, I know that the end goal or the end sort of manufacturing method of this part is going to be 3D printing, which means I don't have to worry about consistent wall thickness, and I don't have to really think about shelling or thickening a surface to get that consistent wall thickness. So with that in mind, I'm going to just build out the inside volume, the place where all the air is going, and then worry about the outside shape on its own, and then I can subtract the two, take away that inside volume. The second thing that I need to think about are going to be things like obstructions or things I want to avoid. Now, in this case, we need to make sure that we don't build into other solid geometry, and we don't want to touch the actual hot portion of the extruder head. We want to make sure that we give it plenty of clearance and that we're pointing at the nozzle or the tip itself. We also need to make sure we don't come below the bottom of the tip, because then we're going to be hitting the build itself, and that's obviously not going to be very beneficial. So once you decide if you're building the inside volume or if you're building the outside shape and you're going to try to shell it, Then you need to think about your modeling approach. Am I going to use solids or surfaces or forms or some combination of all of those? Now, I will say that choosing forms is going to help give nice organic shapes. You can use a pipe network and build out where this thing is going. However, forms is always going to require you to use surface or solid tools after the fact. So it's almost always a hybrid approach. Same thing with surfaces. You're not going to end with a surface. You need to turn it into a solid at some point. So the only singular modeling approach that we could take is with our solid tools. So for this example, I am going to start with doing solid tools. Now I've thought about this process a little bit before, and we're going to go through and we're going to make a unique model. And some things might work, some things might not work. And that's generally the process I like to take. I like to sort of do this from scratch and sort of work through it. But I will say that we're not building an entire design here. We're only going to build part of it, but hopefully the process is helpful. So knowing that I'm building the internal volume, the first step for me is to build the inlets and the outlets to the design, and then I can worry about connecting them together. So the first thing I want to do is I'm going to activate this fan mount, and I'm going to begin making a mid-plane that is centered on the extruder head. So this little heating block here, it says it's giving me a warning, and that's because the construction folder is currently hidden. We're going to say OK, and now we've got that plane right in the middle. The next thing I want to do is make an offset of that plane, and this is going to be where the opening or the exit is for whatever duct system I create. So 20 millimeters, 15 millimeters, somewhere in here. That's probably going to be about right, but doing this with a plane is going to mean that we can manipulate it and move it later as needed. Now that I have the plane, I want to start a new sketch, and I want to figure out where that nozzle needs to be. Now, obviously, it needs to be above the bottom, and that's because we can't go below that. That's where the extruded plastic is coming out, and that's going to obviously be right at the build plate. But I am going to take this bottom edge and project it with P on the keyboard, and then I'm going to use my line tool from the midpoint and just sort of drag this up. I'm going to select these and hit X on the keyboard to convert them to construction, and now I have a centerline reference for whatever the outlet's going to be. Now, because we are going to be dealing with solids, I'm not really worried about organic freeform shapes. I'm going to use the slot and a center point slot from here. Just drag it out and sort of visualize the opening that we need. Now, again, depending on the specs of the fan, how much back pressure it can take, how much flow we want, you would need to play around with these different opening sizes. Because I'm going to assume that nobody is building this duct system for this specific machine here, other than the person that sent me this, I'm not really too worried about dimensions here, but we are going to add some dimensions just to go through the process. So I'm going to say 10, and I'm going to give this a radius of 2.5, and let's make it 3.75. These are all roughly numbers that were about the size of how I dragged that shape out. So that's where those numbers are coming from. There's no magical formula I'm using to try to calculate flow. So now that we have this, the sketches folder is hidden, so let's go ahead and show that. And I'm going to extrude this out. 3 millimeters should be okay. That gives me enough to work with. Now that I have that, I'm going to mirror it to the other side and make sure that it's in the correct position on the other side as well. I know that mid-plane should be right, but we want to make sure we're not hitting the bearing or anything for any of the other axes. So it looks like the mounting plate, we're not really hitting anything. We've got plenty of clearance, so that all looks pretty good. Next, I want to build out the outlet, which is essentially the inlet for this duct system from the fan. Now, the way that these work is there's a small recess here. So I'm just going to select that face, and I'm going to hit extrude. But I want to extrude it from an object. So I'm going to take, there's a little exterior lip here. Then I'm going to extrude it 3 millimeters, just like the end pieces that are pointing at the nozzle. So this gives me the geometry I need to connect. This is my starting point in 3D space. So then the next thing that we need to remember is that these fans are very efficient in a very small percentage of the opening. As I mentioned, at about 50%, they start to drop off drastically with the amount of flow and pressure that's happening over here. So it makes sense for us to neck this down. And the way I'm going to do this is to create an offset plane. I'm going to bring this down, let's say about 10 millimeters. and create a sketch on here. Now, what I want to do is I want to neck this down, and I want to, let's say, use this as a reference, so P to project it. Go back to that bottom view, and I want to offset it inward and go to about 50%, which is right in the middle. So I can give this a midpoint constraint, and then I can use my dimension tool to offset it in 1 millimeter. And over here, I'm just going to click on that 1 to make sure it's equal. And oftentimes, we'll create multiple cross sections for lofting down too, but in this case, I want to do it one at a time. So I'm going to go create a loft. I'm going to go from this face to this face, and I'm going to make sure that they are tangent. This one's going to have a direction, and that's going to drive the shape. That looks pretty good, and we'll combine them together. So once again, what we're doing is we're building out the shape of the inside. I'm going to hide the fasteners. I don't really need to see them, but I want to make sure that we are clearing this right here. Now, we do need to remember this is the inside shape. Now, the inside shape is obviously not the outside shape, which means that we do need to still have material here. So that means that I need to make this a little bit smaller. It's very easy for us to do. We'll just go back to that last sketch. We'll show it. We'll right-click and show its dimensions. And then I'll change this 1 millimeter to a 2 millimeter. We'll just neck it down a bit more, and that'll give us an additional 1 millimeter of clearance here. That should be plenty to have some sort of housing. If it's not, we can always increase that, let's say 2.5, and just continue to neck that down. Now, at this point, you can see that we've got this rectangular section, and I think the best thing for me to do is just select it and hit E on the keyboard to extrude it. And I'm going to extrude it straight down. I want to come down, obviously not below the nozzle, but come down to a point that makes sense. 15.5 looks good. Because the loft used the direction here, we know that this is tangents, or at least curvature, continuous across that edge. So we're going to join those together. And now we're building out that volume. Now, at this point, we're going to have to change directions and go over to this face. And what I want to do is use my fillet tool on these bottom edges, and I want to start to round this off. So 5 millimeters, it looks pretty good. I'm going to say OK. And then I need to sort of extend this out, but I need to break it up a little bit more. Now, these are planar faces, so I can create a sketch directly on it. And what I want to do is create some sort of arc that starts at this one and has tangency, and I'll do the same thing over here. And then I'm going to use my line tool. This line will be horizontal, and we'll also have tangency with these arcs. That should clean things up a bit. It'll let me pull this up and down and decide what radius I want here. And I'm going to go with 2.5. So it doesn't need to match what's on the bottom. But what I want to do is I want to build out a shape. I can extrude this out and say 2 millimeters. I'm going to build out that shape that we're going to use to connect these together. And I'm going to do the same thing on the other side using that same sketch. I'm going to say extrude, hold down the left mouse button to select that profile. We are going to start from this face, and we're going to come out minus 2 millimeters. So join it together with the other side as well. One thing that we want to do before we get too much further is we want to try to fillet these edges. I'm going to go all the way up to 2 millimeters. It's failing. Let's try 1, and it looks like 1 works okay. It's probably failing at 2 just because of the distance of this edge right here, but 1.5 looks okay. I'm going to hold down Control and do it on the other side, make sure it works there as well. And now we've got that sort of smooth transition. That looks pretty good. All right, so now we're moving toward the right direction. The next thing that we need to do is we need to build a profile at 90 degrees from these faces where it's going to transition them together. Now, at this point, if I determine that this piece is too far out in space, I can always go back and I can change the plane that was used to create that. So remember, we created a midplane, and then we created this offset plane. If I edit this offset plane, I can pull those inward. So let's go ahead and just edit this feature. And instead of 20, I'm going to say 14 millimeters. And it pulls those inward a little bit closer to that nozzle. And that gives me less of an arc that I have to make here. So now I'm just going to pick a face that makes sense. I think the outside of this duct here, I'm going to select that and create a sketch. And again, we're going to project, so P on the keyboard. This is going to be used as a reference, so a line from the midpoint just to give me a visual reference here. And then I want to create whatever shape I need to transition between that slot and this one here. This could be a circle, it could be another slot, it could be some sort of organic spline. At this point, because everything we've done has been arcs and slots, I would suggest that it is a slot, but it doesn't have to be. So I'm going to go midpoint there and build this out. Again, I'm going to leave it underdefined for now. But one thing that we do want to consider is we don't want to go below this edge here. So if you want to use it as a reference, you can always project it. And I'm just going to draw this line as a reference. It doesn't need to be there, but just visually so we can make sure that we're not going too low. And drag these things around. Once I'm happy with the rough location, I can create my loft. So at this point, we haven't done any surface, any form work. We're just building out these solid bodies. We're going to use tangency. And that looks pretty good. And I think the transition's pretty good. Corners like this would likely be problematic if we try to offset or thicken this. We will try to shell this, but again, it's just to see if we can do it. It's not really needed. I'm going to do the same thing on the other side. I'm going to create a sketch. P to project. We'll grab this edge just as a reference. Again, we'll grab this bottom piece as a reference. Draw a horizontal line to make sure that we're not going down too low. We'll draw a horizontal line from the midpoint here again, and then we use the slot tool. So a lot of repetition that happens in design. You're going to just do the same thing over and over again, and it's just kind of the nature of it. But once you find a process that works, you can create complex designs relatively quickly, as long as you have a good understanding of what the geometry needs to look like. So we're going to go between these three. Once again, we'll use the same inputs, tangent, just drive in that direction. In this case, curvature isn't really going to make a difference because everything was extruded, everything's straight. It doesn't have curvature in the other direction. So tangent or curvature constraint really isn't going to matter. But I think that position looks pretty good. I'm going to say okay. Let's join together. I'm going to go into my construction and hide that mid plane. I'm going to go ahead and rename it mid just in case I need to come back to it for some reason. And now we have the internal volume of that duct system. So now what this means is you could build out the external shape and just simply subtract this out as an internal volume. As a test, I'm going to go ahead and hide everything else. And I'm just going to try to shell this just to see if it does shell. So let's go ahead and just select this. And I'm going to try it at 1 millimeter, see if it works. And you can see with the shell tool, it's highlighting this as a problem. It says it can't offset that value. Now, if your workflow is to use a thicken or a shell, and this does come up, then you want to use your curvature map analysis. We're going to go to principal maximum and put in whatever thickness value you're trying to achieve. So in this case, I'm trying to go 1 millimeter. And if we rotate this around, you can see everything is green except for this edge right here. So something happened with this edge that is preventing me from creating my shell or my thicken or my offset. If I go to 2, you can see all those 2 millimeter fillets are starting to show up, and those could potentially be problematic. This little red spot here is potentially problematic. Now Fusion's pretty good with fillets because it can extend those planar faces out and create a sharp corner on the inside of a shell, but it cannot handle these spots here. These are problematic. And we can see that also if we go to our surface tools and we select offset, for example. I'm going to turn off chain selection and just try to offset this. If I try to go out 1 millimeter, you can see that it does work, but look what's happening at this edge here. You can see that it's sort of creating its own crease. If I go 0.5, it looks quite a bit better. If I try to go negative, go inward, it's creating it. But once I go to, let's say, -1, let's say okay. If we hide this, hide the solid body, you can see it creates this weird edge, this seam that's happening here. And that's why you're getting the problem with shell. Now, that doesn't mean you can't create something with this. Obviously, we created the offset inward, so we would be able to, say, create an offset inward of this or outward of this. So if we try to, let's say, create an offset on the exterior, we're going to chain selection because we do have fillets everywhere, and try to make it 1 millimeter external. You can see that we are able to build that. Even though there is a problem in this corner here, we are able to build it. Now, this is something that we would need to address. We might need to go back to that loft and play around with the dimensions. We might need to just cut that out and patch it in order to get this to work. But these are the reasons why things like shell aren't working. But sometimes you can get around that by doing an offset surface and then just fixing the problem. Again, not really the intent of what we're doing here because we are looking at building this out as a solid body. But those are things that you're going to run into if you're doing these types of designs. Now, the next thing that we would need to do, again, is to just build out the rest of this design. And as I said, this could just be simple solid body that you extrude or you are going to simply just take this away from. Now, I'm not going to take the time to really do that as just kind of, we've already sort of done it, but let's do just a little bit so we can see that process. I'm going to take that top piece, I'm going to offset it out 1 millimeter, and I'm going to extrude it. I'm just going to go ahead and extrude it straight down as a new body. And again, we built out the internal volume of this so that we were trying to avoid the, going below the nozzle. And you can see that we weren't able to with the final volume. So we would need to make some adjustments. That final solid piece looks like it's right at the nozzle. That's okay. But again, now if we take these two and we say that this is our target body, we want to remove this body. I'm going to keep the tools, so I will still have a version of that. And then now I've cut away that internal volume from this part. Now again, if you're 3D printing this, the thickness doesn't really matter. Obviously, you could offset externally, you could offset the shape, but you could obviously just do a 90% infill on this design, and anywhere that's over 1 millimeter, let's say, it's just some sort of infill shape. So that way it would keep the part relatively simple to design, but you would still get the internal shape that you're looking for. This also lets you get away with building out complex tabs and features to mount to, say, the fan or to mount to something else without having to worry about all of the offset or the thickness or the shell. But once again, the intent of this video wasn't to go through the entire design process to build this out, but it was to show the thought process behind making these design decisions. We didn't use any surfaces really, we didn't use any forms, but we built out the flow path for the fan using this method of building out that internal volume that is essentially a sacrificial part. It's just going to get cut away from something else. But sometimes you need to build in those negative spaces to build out these complex shapes. If you have any questions about this, please let me know. I always appreciate the comments and the design challenges that you're running into, and hopefully we can come up with some design solutions to help you. So again, if you have any questions or comments, please let me know. As always, thanks for watching, and we'll see you in the next one.